Okay, gentlemen. So far we've covered slope, rise over run. We've talked about y2 minus y1 over x2 minus x1, or change in y over change in x, which can also be referred to with a little delta, a little triangle, right? Delta y over delta x. We've also talked about it as a unit rate. It represents m in the equation y equal mx plus b. And so today we're just going to answer a couple of questions. We're going to apply our knowledge to something different that we haven't seen before. So here it says determine the length of each vertical brace. It says here a ramp needs to have a slope of 3/5. So if the slope is 3/5, we know that as a unit rate, what we would have to do is take 3 divided by 5, which is the same thing as saying 0.6. How do I know that that's 0.6? Because 3 divided by 5 is 0.6, but also you can look at an equivalent fraction. So 3 out of 5 is the same as saying what out of 10, right? We look at our scale factor, 5 times 2. So then 3 times 2 would be 6, and 6/10 is really 0.6. Okay, so in this case, it's meters. So 0.6 meters. That means every little brace here, the rise over run, that has to be 0.6. If the run is 1 meter here, then the rise is 0.6. But for a run of 2 meters, then what would the rise be there? Another 0.6, right? Because it's consistent. If this is linear, right? If that slope is linear, then we have to make sure that we have a consistent increase. Every time we increase 1 meter on the x-axis, so to speak, we have 0.6 meter rise on the y. In this case, it's talking about the braces, each vertical brace. Remember, vertical is the y-axis or the dependent variable. So this would be 1.2 meters, right? Let me change that to meters there as well. And then if we were going up the third, we go from here to here, we'd be doing another 0.6. So that'd be 1.8 meters. And this trend would continue on and on and on. So what would it be if we continued again? Let me just try and find another color here. So if we took purple here, I'm going to go here, 1.8. Now you're at 2.4 meters. And then, of course, you would expect that over a 5 meter as a denominator, or the run, the numerator, oops, that's a little bit terrible there. The rise would have to be 3.0 because we are told in the question that it's 3 divided by 5. And if you add up all the 1 meters in the bottom, you have 5 of them there, and the total rise should be 3. Okay, if we did our work properly, 3 over 5. So the unit rate is 0.6. Okay, and now we're asked to fill in this table of values. So there's a hint, graph the line and complete a table of values, right? We know that when x is 0, that would be this point right here. When x is 0, when we haven't even started this bridge yet, okay, or this ramp, we haven't even started it, what's the rise? Nothing. So we know that when x is 0, y is also 0. If you remember correctly, that is also direct variation, right? If a line passes through the coordinate 0, 0, also known as the origin, then it has a direct variation. They're directly related. So if I wanted to make my life a little easier, first of all, I'll put a dot here at 0, 0. Let me use a dark, yeah, that's fine. We'll use a 0, 0 right there. Again, direct variation passes through 0, 0. I already know that when x is 5, the rise is 3. We learned that from just looking at our diagram above there, right? We had 5 meters and a rise of 3. If I continue that pattern over 5, up 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, up 3, I'd get another one here. Well, see, does that make sense? That looks like the coordinate 6. Sorry, I apologize. 10, 6. 10, 6. Well, I had 5, 3, right? Remember, this is the y, this is the x, or 3 over 5, and the 3 became a 6, and the 5 became a 10. They're both doubled. That makes sense. So my line can easily be drawn if I wanted to like this, right? Draw an arrow here. I might even go a little past. I know I can't draw it as straight as you can, maybe with a ruler right now, but you get the hint. That goes through with an arrow on both sides to show that the line is infinite and runs infinitely in both directions. Okay, again, obviously I would expect a little bit neater with a ruler. That's probably a better one. See if I can erase that a little bit there. Good. Okay, so if I want to plug in values, I can simply plug in 0 for x, get 0 for y. I can plug in 5 for x and get 3 for y. I can plug in 10 for x and get 6. And you can see that this pattern can continue. You could do it another way as well. If you wanted to, you could use when x is 0, y is 0. When x is 1, y is 0.6. When x is 2, y is 1.2. And you could follow that pattern above that we saw over there. That's also possible. I thought whole numbers would be nice and easy to graph. And that's really all I need for that table of values. Okay, let's look at the learning goal. The rate of change is the change in one quantity relative to the change in another. So here we're talking about the change in x. Every time we make one more meter for the brace, we need an extra 0.6 meters on the vertical. So this bridge or ramp, sorry, as we go on the x-axis, each meter of ramp or the length of that ramp requires an extra brace that's 0.6 meters taller each time. And that's the constant of variation, right? Over 1, up 0.6, over 1, up another 0.6, et cetera, et cetera. A rate of change requires units, right? Here we have meters, but it could be kilometers per hour. It could be dollars per hour. When a relation is graphed, the slope describes the rate of change, just like the slope could describe speed if it's distance over time. To find the slope of a line segment joining two coordinates, we subtract the y values, y2 minus y1, and then the x values, x2 minus x1, to get the run. So here we're going to apply that formula, and we're going to start off with a is negative 6, 4, and b is 2, negative 8. Now we have to choose which set of coordinates is going to be our first set and which set of coordinates is going to be our second set of coordinates. So here's how we'll run. The slope of line AB, and here's the proper math notation. So the lowercase m to represent slope, and then a capital AB next to each other with a line on top means line AB. So the slope of line AB is equal to y2 minus y1 over x2 minus x1. Now, if I want to color coordinate this for you, let me redo that. If I want to color coordinate so you understand which coordinates I chose as my first and second, I've actually chosen the pink coordinates, or B, as my second set. Okay, and so obviously that's going to be x2 minus y1 over x2 minus x1. And remember I said try and keep those numbers down low. They're subscript, okay? It represents the second y coordinate. It's not squared units. So careful how you're writing that. So we want a slope of AB. What we're going to sub in negative 8 for y2. Let me put that in color again. Negative 8 minus y1, which would be the 4. So y2 minus y1, and then x2 minus x1. That's what we're going to do. So x2 is automatically 2. Because I chose negative 8 as my second y, the 2 here is automatically my second x, because B is my second set of coordinates. They must stick together that way. There's no mixing and matching. So then I have 2 minus negative 6. But I know that 2 minus negative is really addition. So I can write 2 plus 6. Now, if you're not comfortable with that right off the bat, that's fine. If you need to write minus negative 6, that's fine. But in the next step, you're going to have to change that to, or add 2 plus 6. So I'm okay with it right now. But as you get more proficient, I would expect that you just write 2 plus 6. Okay? That's going to equal negative 8 minus 4 is negative 12. And 2 plus 6 is 8. And we can reduce that. 4 goes into 12 3 times, but it's negative. So I'll put the negative in the middle. So that's 3, and 4 goes into 8 twice. Remember, it doesn't matter who gets the negative. It can go to the 3 if you like, or the 2, but either or and not both, because if they're both negative, then it's positive. Then the question says, find the slope of BA. We covered this in some of our EDSB entrance tickets. So let's look and see if we reverse the coordinates and I write this as BA. Okay. So now I'm going to choose A as my second set of coordinates. Let me erase that. And we're going to go the reverse order. We'll make this our first set, and we'll make the B values we'll make A values our second set and B values the first set. So now we're going to have Y2 will be 4 this time. Okay, so y2, we'll have x2 here, minus y1. Always start with a formula over x1. And so now we're going to have 4 minus -8, which is plus 8. Y2, we're going this way, right? 4 minus -8 and -6 minus 2. Draw my line. -6 minus 2. And so in the numerator, I get positive 12. In the denominator, I get -8. And again, the negative is going to go in the middle, and 4 goes into 12 3 times. It goes into 8 twice. And lo and behold, we have the exact same slope, so it does not matter. Okay. If I wanted to graph A, it's at -6 4, right there. If I want to graph B, it's 2 -8. 2 -8 is off the grid. You see that? I only go to -6. So if I want to get down to -8, we do not extend the grid and make these little radio antennas that go down. What the goal is here is for you to understand, how can I use the slope to find my line? Well, I wanted to use those 2 coordinates and just draw a line between them, but I can't because I'm off the grid. So what else can I do? I can use my knowledge of slope. My slope tells me to go down 3 and right 2 if I give the negative to the numerator. Negative numerator controls y, and that would mean go down. If I give the negative to the denominator, then it means the numerator is automatically positive. Then I would go up 3 and left 2. Do I want to go up 3 from here? No, because I'd also be off the grid. So I'm going to give the negative to the 3, and I'm going to go down 3, 1, 2, 3, and I'm going to go right 2. So I'm here. You do not have to draw arrows, what have you. You can literally just draw your dots. Okay, so down 1, 2, 3, right 2, and I'll draw another dot. 1, 2, 3, right 2, and draw another dot. I really don't need to go any further. That's good enough. Okay, and then I'll just draw my, again, with a ruler, I'd expect a little bit better and from you. And there you go. Okay, so that went obviously down 3, right 2, down 3, right 2. You can see that. It's consistent. Okay. All right, so that's how we do the graph. A teenager's heart pumps an average of 7,200 liters, 7,200 liters of blood every 24 hours. What is the rate of change? They're looking for liters per hour. Okay, we're dealing with liters here and hours. So we want liters is going to be on the y-axis, and the time or the hours is on the x-axis, because time is independent variable, and the amount of blood would be, the liters would be on the y-axis. How much blood is pumped depends, how much the blood the heart pumps every hour depends. How much blood the heart pumps depends on how many hours or how much time it's pumping for. So in this case, we're really going to just take 7,200, the y, divided by 24. Now you don't have to write L and H here because we're just performing a calculation. Okay. 7,200 divided by 24 equal, and you can take out your handy dandy calculator to calculate that. I've already got it calculated earlier, and it comes out to 300 liters per hour. Okay, so 300 capital L / H. And that's it. That's your answer. It's 300 liters per hour. This could be something as simple as a car traveled 240 kilometers in 3 hours. 240 divided by 3 is 80. So on average, it traveled 80 kilometers per hour. Okay. This graph shows the relationship between temperature and altitude. Okay. So what's happening just by reading the graph, as you read the graph left to right, it seems like the temperature is dropping as the altitude is increasing. Okay, so as the x increases, the y decreases. Kind of an inverse relationship there, right? One's going up and the other one's going down. So as you climb higher, the temperature drops lower. That's why you see snow-capped mountains when you go to British Columbia or what have you, right? You can be swimming at the base of a mountain, but you go way up there, and as you get higher, the temperature is dropping. So this is saying calculate the slope of the graph. No problem. We're given 2 coordinates, 225 and here. So I'm going to write those coordinates. I like to write those over here where I'm doing my work. Now that's just me. I don't like to look back and forth across the page. So I'll write that one here, and I'll write this one here, 2213. Okay, so I know this to calculate slope equal again, y2 minus y1 over x2 minus x1. And we get 13 minus 25, right? I'm going to call these my y's, the 13 and the 25. And my x's are the 2200 and the 200. But I have to follow the same order. Because I use the 13 as my y2, then I have to use my 2200 as my x2. So 2200 minus 200, okay? And again, as a form of habit, I like to just be methodical about how I perform this calculation. So because I'm looking at this question, this coordinate came first in the question, this coordinate came second. So what I do just to save myself from making errors, whatever comes first, I count as my first set of coordinates. Whatever comes second, I count as my second set of coordinates. So 13 minus 25, negative 12. And 2200 minus 200 is 2000. Now you could divide that by 4. Most of you can do that in your head. 12 divided by 4 is 3. So right, equal negative 3 over, and that's 500. Right? If I divide 2000 by 4, this actually looks a little familiar. It looks like the question we had at the beginning, 3 divided by 5. Remember, 3 divided by 5 was 0.6. This is negative. So I know my answer automatically is going to be a negative, but it's 0 decimal, not 6, because if 3 divided by 5 was 6, 3 divided by 50 would make me push that. Sorry, because it's 500, I've got to now move the decimal over 2 more times. So I have to have decimal 0, 0, 6. Okay. So every time I went from 50 and then went to 500, we had to move the decimal over once and then again. Okay. So now we're at decimal 0, 0, 6. How do I know that that's true? Another way of thinking about that is this is really 3 out of 500 or negative 3 out of 500. And if I doubled that, it would be 6 out of 1,000. That means the 6 goes in the thousandths column. Okay, that's another way of looking at that. But how do I interpret this? It says interpret the slope as a rate of change. That's question B. That means that, I'm not sure if I can type in there. That might make my life a lot easier if I could. And for every meter of altitude, temperature drops by decimal 0.006 degrees. You'll put a 0 in front of that. Okay, that's what it means. For every meter of altitude, maybe we could say for every meter increase in altitude. That sounds a little more clear, doesn't it? And I gotta get this guy to join the group. Drops by decimal 0.006 degrees. Okay. There you go. And that's 5.4 day 1. See you later.